Okay, let's look at problems 13.9 and 13.10. They're kind of similar-ish. We're looking at the function 2 to the x, right? So an exponential 2 to a power, not e to a power, a little bit less than e, right? 2 to the power. And then they want us to graph it, and then graphs we're doing things to the function, okay? So first, let's graph this. So, I'll put all the axes here. So let's just pick 2 points, and we'll just follow those 2 points as we shift and dilate and all that kind of stuff. Okay, that should be good enough. So let's choose x equals 0. At 0, 2 to the 0 is 1. So let's make that here. So there's 0, 1, 0, 1. And then let's do x equals 2. 2 squared is 4. So if that's 1, here's 2. So 2, 4, there's 1. 4 is up here. Okay, so, and then I know that it goes this way, can never be negative. We can never get this thing negative. 2 to the power is never negative. We can make it small if we have 2 to the negative 10. That's like 1 over 2 to the 10. 2 to the 10 is a huge number, so that's a tiny fraction. But we can't make it negative, so it kind of rolls out like this, but then it gets big really fast, right? Exponential growth. 2 to the power, right? Talking exponential growth here. All right, so they say now to write in standard exponential form, and if you remember, standard exponential form is y is a0 b to the x. This is standard exponential form because it's a0 is 1. You don't have an a0, so it's 1. B is 2, and then b to the x. So now they say that I'm going to do the hardest one. I'll let you guys do the other one. So 3f of 2x minus 1. So this is the last one for a1. They say 3f of 2 times x minus 1. We want to write that, is that right? 3f 2 times x minus 1. That's right. Write it in standard form. All right. So what we just do is we take our function, wherever there's an x, we plug in 2x minus 1, and we multiply it by 3. So this is y is equal to 3 times 2 to the 2x minus 1. So let's just multiply that out. So that's 3 times 2 to the 2x minus 2, which is 3 times 2 to the 2x times 2 to the negative 2, right? Because 2x, same base, 2x times 2 to the negative 2 is 2x minus 2. Yep, that's right. 2 to the negative 2 is 1/4. That's 1 over 2 squared, right? So that's 1 over 2 squared, which is 1/4. So that just becomes a constant in front. So that's then 3/4. The 3 times 1/4. And 3/4 times 2 squared to the x. Right? 2 to the 2x is 2 squared to the x, because multiply exponents. X times 2 is 2x. 2 squared is 4. So finally, we have 3/4 times 4 to the x. That is in standard exponential form. Okay, so then they say, is the function, if we added 1 of exponential type. So the next part they say, what if we just took that and added 1 to it? What would that look like? Okay, so they call that A2. So this must be A1, I guess, part of A1. So A2, let's look at this one now. We add 1 to it. So if we add 1 to it, we get this plus 1. Or this plus 1, or this plus 1. Everything is plus 1 is plus 1. So, right, because all I'm doing is adding 1 to our function. So then it'd be y is equal to 3/4 4 to the x plus 1. That, I can't put that 1 in with the rest of it. It doesn't work. You just can't combine that 1. I can never write that as, it's impossible to write that as some number times a base to the x. Because we got that 1 there, I can't put that 1, somehow mix it into here. So it's not exponential type. So I guess the idea there is if you shift in the y value, it's not going to be an exponential. We can't write it as something times b to the x. Yeah, that's just kind of interesting. Yeah, can't do it. So that's kind of cool. Okay, Let's see. Then problem 1310. Okay, then A3 says to graph those things. Okay, so let's graph this one that we just did. So what we're doing is we could look at this and graph it. Okay, so 4 to the x, we could do that. Or we could look at this and do our whole shifting thing. Okay, we could take those points and shift them. Let's do it that way. This point here is 2, 4. So let's see what happens. Let's do a rule for this and shift it. Now without the 1, because that was the problem I just did. Okay, so where should I do that? I'll do that over here. So our rule here is first we dilate by 2. If we have a 2 times both of them, we dilate first. Now the other thing we could do is write it as 2x minus 2, and then we shift by 2, and then dilate by 2. But if we have 2 times x minus 1, then we dilate, and then we shift. It's kind of like the order that if you were to solve for x, if I was to solve for x here, I got to get rid of that 2 first, so I deal with it first. If I was to solve for x here, I get rid of this 2 first. I shift first. So it kind of makes sense, right? Which one do you do first? Here to get x, I shift. Here to get x, I have to do the 2. So that means I multiply by 1/2. I make it smaller, so I shrink it in the x direction by 1/2. Then I shift it right, to this minus 1. Then I shift it right by 1, so I add 1 to x. Then I multiply it by 3 in the y direction, and by 3. Okay, so our point 0, 1 becomes, see, multiply it by 1/2, it's still 0, add 1, so the x value becomes 1. Multiply, by 1/2, still 0. And then the y value, we just multiply it by 3, so it becomes 1, 3. And then the other point we're looking at, 2, 4, multiply it by 1/2, the x by 1/2, that's 1, add 1 becomes 2. Multiply it by 1/2, 1, add 1 becomes 2. So it stays in the same place. That's pretty crazy. Can that be right? 1/2, add 1, yeah. And then the y value, we multiply it by 3, becomes 12. Okay, so our new points are 0, 1 becomes 1, 3. So 1, 3. And the y value becomes 2, 12. So 2, 12, oh my gosh, 2, 12. This is 4. It's way up there. I'm not going to bother to get it right. So, and I'd find that you guys would do that either. So let's see, it goes like this. It gets bigger really fast. And let's see, what if when it's 0, we get, I can just look at this. When 0, we get 3/4. So it goes through 3/4. X equals 0, y is 3/4. So it's like right there. So it goes like this. Crazy. Gets bigger really, really fast, looks like. Okay, that's the idea with doing this. Now let's look at 1310. It's really similar. Now they say again, begin with the graph of 2 to the x, the blue graph here. And now graph these other things. So let's look at a hard one. Let's do y equals, I don't know if any of them are really hard. But 2 to the x minus 2? I don't know. So this is 1310. So 1310. And they say, starting with our graph of 2 to the x, the blue one here, we'll graph 2 to the x, 2 to the x minus 2. So graph 2 to the x minus 2. So if f of x is equal to 2 to the x, then this is f of x minus 2. Right? Because we just place the x with x minus 2, we get x minus 2. So all we're doing is shifting it to the right, shifting to the right 2. So this dot goes here to 2, this dot goes here to 2, goes right 2, but it looks exactly the same, so it kind of goes down and goes up like that. We're just taking the blue graph and shifting it over 2. Okay, that's pretty easy. Is there any trickier ones? These are not that hard. Yeah, that's all. You're just saying what you would do to the graph. If you're, it's a little bit tricky. Like if we're like they say y equals 3 times 2 to the x. Now we're multiplying it by 3 2 to the x. We are expanding it by 3. We're making it bigger in the y direction by 3. So every y value we multiply by 3. We take this y value, it becomes 3 bigger. It goes from 1 to 3, so it's right here. This one goes from 4 to 12, way the heck up there. And yeah, so then it looks something like this. Right? It's kind of hard to draw when they get really big numbers like that, but it's the idea that counts. It's just getting the idea right to see how these things work. Okay, good. Hope that helps. You can figure out the rest.